यज्ञस्य देवमृत्विजं होतारं रत्नधातमम् ॐ अग्नेः पूर्वेभिरिषिभिरिड्यो नूतनेरुत स देवा एह भक्षते ॐ अग्नेन रहिमस्नबत् ओषमेव दिवे दिवे यशसं वीरवत्वमम् ॐ पूर्णमदः पूर्णमिदं पूर्णात् पूर्णमुदच्यते पूर्णस्य पूर्णमादाय पूर्णमेवावशिष्यते ॐ शान्ति शान्ति शान्तिः ॐ श्री गुरुभ्यो नमः हरिः ॐ नमो नमः
सर्वेभ्यो नमो नमः। श्रूयते?
आं श्रूयते श्रूयते कथयन्तु।
आम्। अस्माकं महत् सौभाग्यमिदं यत् अद्य बाकुडा विश्वविद्यालयस्य संस्कृतविभागे संस्कृत सप्ताहम् उपलक्ष्य संस्कृतं संगणकीयभाषाविज्ञानं च इति विषयम् अवलम्ब्य अन्तर्जालमाध्यमेन विशिष्टभाषणसत्रम् आयोजितम् अस्ति। अत्र व्याख्यातृपदम् अलङ्कुर्वन्ति जवाहरलाल नेहरू विश्वविद्यालयस्य अध्यापकः प्रोफेसर गिरीश नाथ झा महोदयः। अत्र भवतां सर्वेषां स्वागतम्। अस्यां सभायाम् अस्माकं कुलसचिवाः समुपस्थिताः सन्ति। यद्यपि अस्यां सभायाम् अस्माकं कुलपतयः न सन्ति, तथापि सर्वेषां कृते वार्ता महाभागे प्रेषितः। कुलपतयः उक्तवन्तः यत् बाकुडा विश्वविद्यालयस्य पक्षतः अध्यापकेभ्यः गिरीशनाथ झा महाभागेभ्यः स्वानन्द स्वागतं व्याहरामि। ततश्च सर्वेभ्यः श्रोतृभ्यः सुस्वागतं विज्ञापयामि। यथा इदम् अनुष्ठानं निर्विघ्नं स्यात् तथा अहं कामये इति। भवद्भिः ज्ञायन्ते यत् एव कस्यापि अनुष्ठानस्य सम्यक् निर्विघ्न परिसमाप्तये आदौ एव मंगलाचरणं क्रियते। अत्रापि अद्य अनुष्ठानं निर्विघ्न परिसमाप्तये वैदिक मंगलाचरणं करोति एव कृतवान् एव करोति अस्माकं संस्कृत विभागस्य छात्रः संजीव कुम्भकारः। पुनः एकवारं कुम्भकारः।
आम्।
प्रारम्भं करोतु।
ॐ अग्निमीळे पुरहितं यज्ञस्य देवमृत्विजं होतारं रत्नधातमम् ॐ अग्नेः पूर्वेभिरिषिभिरिड्यो नूतनैरुत स देवा एह वक्षते ॐ अग्निना रयिमस्नवत् पोषमेव दिवे दिवे यशसं वीरवत्तमम् ॐ पूर्णमदः पूर्णमिदं पूर्णात् पूर्णमुदच्यते पूर्णस्य पूर्णमादाय पूर्णमेवावशिष्यते ॐ शान्ति शान्ति शान्तिः ॐ श्री गुरुभ्यो नमः हरिः ॐ नमो नमः।
नमोनाय संजित। अतः परम अनुष्ठाने स्वागत भाषणाय अस्माकं विश्वविद्यालयस्य संस्कृतविभागस्य अध्यापकः न्यायदर्शनविशारदः महा सन्तु महाभागा अनु
श्रूयते मम ध्वनिः? हरि ओम, श्रूयते मम ध्वनिः? श्रूयते?
आं महोदय
आं
श्रूयते।
श्रूयते।
आम्। ॐ जननी शारदान्ते रामकृष्णं जगद्गुरुं पादपद्मे तयो धृत्वा प्रणमामि मुहुर्मुहुः। ॐ हृदयकमलमध्ये राजितं निरुदिकल्पम् अदसदतितमेकस्वरूपम् प्रकृतिविकृतिशून्यं नित्यमानन्दमूर्तिं विमलपरमहंसं रामकृष्णं भजामः। वितरितुमवतीर्णं ज्ञानशक्तिप्रदातारं रसमाप्तां सर्वेभ्यो नमो नमः। इदम अस्माकं महान प्रमोद विषयः यत् अद्य बांकुड़ा विश्वविद्यालयस्य सुरवाग् विभागे संस्कृत सप्ताहं समुपलक्ष्य आयोजितं विशिष्ट व्याख्यान सत्रमिदम्। अहं विभागीयाध्यापकैः त्रिदीप महाभागैः समादिष्टः स्वागत भाषण उपस्थापनाय। अस्याम् आन्तर्जालिक सभायां समुपस्थिताः अस्माकं बांकुड़ा विश्वविद्यालयस्य कुलसचिव महाभागाः सुवीर रॉय महोदयाः, तेभ्यः महाभागेभ्यः भूयांसि नमांसि आदौ विज्ञापयामि। ततश्च अस्यां सभायां महाभागानाम् आगमनं जातम् इति कृत्वा महाभागेभ्यः सुस्वागतं व्याहरामि। इमे महाभागा यद्यपि सततम् एव व्यस्ताः सन्तः अपि अस्माकं कृते समयं कल्पितवन्तः। तदर्थं महाभागेभ्यः धन्यवादाः अपि विज्ञाप्यन्ते। यतः यदैव मया दूरवाणी कृता महाभागानां कृते यत् अस्माकं विशिष्ट व्याख्यान सत्रं समायोज्यते, कृपया भवन्तः तिष्ठन्तु। सपद्येव महाभागाः अस्माकम् अनुरोधं स्वीकृत्य उक्तवन्तः आम् अवश्यमेव स्थास्यामि इति। यदैव अस्माकं किमपि प्रयोजनं भवति महाभागाः सततमेव तत् प्रयोजनं सम्पादयन्ति। अतः महाभागेभ्यः अस्यां सभायां सुस्वागतं व्याहरामि। ततश्च अस्मिन् विशिष्ट व्याख्याने अस्माभिः लब्धाः केचन महानुभावाः ते हि जवाहरलाल नेहरू विश्वविद्यालयस्य स्कूल ऑफ संस्कृत एंड इंडिक स्टडी इति संस्थायाः प्राध्यापकाः प्रोफेसर गिरीश नाथ झा महोदयाः। इमे महाभागाः सततं निरन्तरं च स्वाध्याय प्रवचनाभ्यान्न प्रमदितव्यम् इति वेदवाक्यम् अनुसरन्तः सततमेव स्वाध्याय प्रवचने निरताः वर्तन्ते। तथापि अस्माकम् अधमानाम् अनुरोधम् इमं स्वीकृत्य अस्मान् अनुगृहीतवन्तः। अतः एतेभ्यः महाभागेभ्यः सश्रद्धं प्रणामादिकम् आदौ विज्ञापयामि। ततश्च अस्यां सभायां महाभागानाम् आगमनं जातम् इति कृत्वा महाभागेभ्यः हार्दिकं सुस्वागतं व्याहरामि। इमे महाभागाः अनन्तरम् अस्माकं सञ्चालक महाभागैः वक्ष्यते एव, तथापि अत्र किञ्चित् अवश्यमेव वक्तव्यम् इति कृत्वा उच्यते। इमे महाभागाः संगणक शास्त्र निष्णाताः तथा च संस्कृत शास्त्र पारंगताः। अनयोः पारम्परिकशास्त्राणां तथा इदानीन्तनीय सङ्गणकीयशास्त्राणां यथा सम्मेलनं स्यात् तत् विचिन्त्य एव आजीवनं कार्यं कुर्वन्तः वर्तन्ते। इमे महाभागाः विदेशेषु नैकेषु लब्धयशस्काः लब्धप्रतिष्ठाः सन्ति। अतः एतादृशानां महाभागानाम् अत्र समागमनं जातम् इति कृत्वा वयं सर्वे एव सानन्दाः स्म। पुनश्च अत्र विषयः यस्तावदस्ति संस्कृतं भाषा संगणकीय भाषा विज्ञानं च विषयमिमम् आश्रित्य एव महाभागानां विशिष्टव्याख्यानं प्रचलिष्यति। कथं प्रचलिष्यति इति अत्र एकवारं शास्त्रीय दिशा विचार्यते। महाभागानां यत्तावत् नामधेयं वर्तते तन्नामधेयमस्ति गिरीशनाथ झा इति। तत्र गिरीशनाथ इत्यस्य यदि अस्माभिः व्युत्पत्तिः क्रियते गिराम् ईशः गिरीशः इति। गिर इति शब्दः यः वर्तते स शब्दः तत्र वाक् इति अर्थं द्योतयति। अतः वाचाम् ईशः तेषु पुनः नाकः एतादृशः अस्ति अस्माकं महाभागानां नामधेयम्। अतः नामधेयात् एव अस्माभिः ज्ञायते कीदृशाः वचननिरताः वचनरताः वचनस्पराः वचनश्रेष्ठाश्च स्युः महाभागाः। एतादृशान् महाभागान् लब्ध्वा वयं सर्वे एव कृतार्थाः। अतः पुनश्च अस्यां सभायां ये तावत् श्रोतृरूपेण विराजन्ते तेभ्यः अपि स्वागतं व्याहरामि इत्युक्त्वा पुनः सर्वेभ्यः यथायोग्यं प्रणाम श्रद्धादिकं विधीय अत्रैवाहं विरमामि। सर्वेभ्यः नमो नमः।
सन्तु महाभागेभ्यः स्वागत भाषणाय धन्यवादः। अस्य अनुष्ठानस्य उद्बोधन भाषणाय बांकुड़ा विश्वविद्यालयस्य कुलसचिवाः अनुरुद्धन्ते। सुबीर महाभागः।
Very good morning, my colleagues in Sanskrit department, Bankura University, including teacher in charge, and respected Professor Girish Nath Jha. He is present in this virtual platform as a resource person and the speaker of the day. We are passing through a peculiar situation. We know it very well. The COVID-19 pandemic has posed the greatest challenge to the very survival and existence of the humankind since Second World War. The pandemic with its ugly face is tormenting the daily life pattern of the human beings throughout the world. Already it has stormed with social, political, economical and cultural changes, social distancing, masking, hand washing, sanitization, cleaning, etc. are going to be a part of our culture. But in midst of challenges, we the human being always quest for something new, the alternatives, and for our academic discourse, we have already invented our alternatives. That is, by virtue of that quality, we all are assembled over here in this virtual space. The more we distance ourselves physically, the more we become very close mentally and physically. I have heard saying Swami Atma Priyananda Maharaj, the Vice Chancellor of the Vivekananda University and respected monk in the Ramakrishna order, saying about J. Krishnamurti, who said that we need to develop a kind of aloneness, not aloneness, aloneness, which is beyond loneliness. That means to develop a kind of cognitive faculty in such a way where we can be able to mingle with each other from our mental sphere, but so far we are lacking that very ability. So through internet we are connecting with each other. Regularly, our university, departments of our university, the colleges of our university, they are organizing the different webinar involving into academic discourses so that the academic interaction, it should not be interrupted by the challenges what has been thrown by this tiny virus. Well, it's a very, very, very significant contribution what the Sanskrit department of Bankura University is going to add. That is a deliberation seminar talk regarding the matter of Sanskrit language. And my heartfelt thanks to Sanskrit department for this noble effort what they have shown by organizing this seminar talk. I do believe that language, it involves the treasures of information. Language represents our culture, our civilization, our own root. And therefore it is the need of the hour to think for the development of all the language. Because already I told you that language embedded itself with the information. That information which helps us to put forward our step. Without that information, we cannot be able to attain our physical, mental, spiritual personality. For that sake, it's very much needed to rear the language. And needless to mention, Sanskrit language, with this language, our own cultural heritage is associated with it. Without knowing this language, without exploring this language further, we will remain in dark about the lots of information related with our own civilization, related with our own cultural heritage. When this is a real part of the phenomenon, the other part is that without having the knowledge, in-depth knowledge about this language, some people are there in this globe who unnecessarily exaggerated the matters and intends to spread something which actually maybe they half true or far from the truth. So it's really the need of the hour to know about this language, to explore the language further, to know our past, our civilization, our glorious past deeds. And for that reason, I am really grateful to Professor Girish Nath for sharing his valuable time with us, for his acceptance to deliver a lecture which will immensely helpful to the academicians, student of this part of the country. I am also thankful to all the participants, includes academicians, students. I am seeing that almost 71 participants have already assembled in this virtual platform. So I am sure this deliberation will go to enhance our cognitive faculty. With these words, thanks to all of you for your kind effort and for your patience hearing. Thanks to all of you.
सचिव महाभागेभ्य उद्बोधन भाषणाय धन्यवादः। अतः परं संपूर्ण कार्यक्रमस्य सञ्चालनाय अस्माकं बाकुडा विश्वविद्यालयस्य संस्कृत विभागस्य व्याकरण विदुष्य मंजी महाभागः अनुरुध्यन्ते इति। मंजी महाभागः।
धन्यवादः त्रिदेवः। सर्वेभ्यः नमो नमः। अत्र सत्रे मम गुरुं प्रोफेसर गिरीश नाथ झा महोदयं पुनः स्वागतं व्याहरामि। प्रोफेसर गिरीश नाथ झा दिल्ली स्थितस्य जवाहरलाल नेहरू विश्वविद्यालयस्य स्कूल ऑफ संस्कृत इंडिक स्टडीज इति केन्द्रस्य प्राध्यापकः। संगणकीय भाषा विज्ञाने प्राचीनेषु ग्रन्थेषु वैज्ञानिकी आलोचना विषयेषु कोश विज्ञाने यन्त्रानुवादेषु अंतर्जालीय शिक्षासु वेब बेस्ड टेक्नोलॉजी RDBMS इत्यादिषु विषयेषु गवेषणायै महाभागानां सुमहान् रुचिः वर्तते। तत्प्रणेता नैक लिखितः ग्रन्थः स्प्रिंगर, भर्लग, केम्ब्रिज स्कॉलर इत्यादि प्रकाशन संस्थाभ्यः प्रकाशितः। भवान् इटाली, इंडोनेशिया, जर्मनी, अमेरिका इत्यादीनां विदेशानां सुप्रसिद्धेषु विश्वविद्यालयेषु अतिथि अध्यापक रूपेण कार्यं कृतवन्तः। तद्रचितेषु 37 संख्याधिकेषु शोधपत्रेषु 26 शोधपत्राणि स्कोपस इत्यत्र परिगणितानि। इमे महाभागाः माइक्रोसॉफ्ट रिसर्च USA, माइक्रोसॉफ्ट रिसर्च इंडिया, स्विफ्ट की इत्यादिषु संस्थासु उपदेष्टि पदवीम् अलम् अकार्षुः। भारतीय सर्वकारीय IT संस्थया सह अपि कृत्यं सम्पादितवन्तः। किं बहुना महानुभावानां एतेषां महाभागां तत्त्वावधाने एतावत् पर्यन्तं 40 छात्राः MPhil इति सम्पादितवन्तः तथा 30 छात्राः PhD इति सम्पादितवन्तः। महन्तः एते महोदयाः संस्कृत भाषा विज्ञान निमित्तः दत्तपाठ पुरस्कारेण भूषितः। पुनः शारदा लिपि प्रचारार्थमपि KECSS फेलिसिटेशन पुरस्कारेण पुरस्कृतः। अधुना महाभागः सश्रद्धं प्रार्थते संस्कृतं संगणकीय भाषा विज्ञानं च इति विषयम् आश्रित्य स वक्तव्य उपस्थापनार्थं। वक्तव्य प्रारम्भे एका सूचना अस्ति। प्रश्नः चैट बॉक्स इत्येषां पेटिकायाम् एव लिखन्तु। यदि आंग्ल संस्कृत भाषायां वा समस्या अस्ति तर्हि बङ्गभाषायाम् अपि प्रश्नः स्वागतः। If anyone have problem in asking question in English or Sanskrit, they can ask in Bangla also in the chat box. Okay. Thank you, sir.
Hello. Hello. Hello.
हाँ सर सुनाई दे रहे हैं
Yes, sir.
Okay.
Yes, sir.
Namo Namah. Sanskrit Saptahasya Subhashya. Thank you, Manji, for that beautiful introduction in Sanskrit. Thank you, Dr. Rai, the registrar of the university, for beautifully presenting the value of languages and how we need to actually carry on working and promoting our languages. Thank you, Dr. Sarkar and Dr. Shingha. And thank you, a student who presented beautifully the Gayatri Mantra. Can everybody see the PPT? Hello?
Yes,
Okay,
sir.
good. Now the topic that I have is talking about Indian languages, computational linguistics in Sanskrit. Now the goal of this presentation is, as Manji told me, that there's a lot of interest in computational linguistics in your department there and in the university in general. And there are, I believe, in Bankura region, a lot of Indian languages being spoken. Actually, a lot of language families, including Santhali, the Austroasiatic languages. So I thought I'll also talk about Indian languages in general, the scene of Indian languages, the need of technology, and then go to the complexity that our culture, our linguistic situation in India presents to artificial intelligence. And then how can AI actually handle it, the complexity that India in general is. And then what is computational linguistics, how it relates to AI and the allied disciplines. And how can Sanskrit come in and help? Now, Sanskrit is the only language perhaps in the entire world today which can help AI progress faster. While we can build technologies for Sanskrit and Hindi and Bangla and other languages, while Hindi, Punjabi, Bangla, etc. cannot help AI to progress, Sanskrit can. And that I'm going to talk about. So this is going to be, in a nutshell, the talk today. Now, the language situation in India, if you look at, well, we are more diverse than any other country in the world. We all know that, and more than 1,600 languages. The number keeps on, going up and down depending on how we are surveying properly. Because the first survey, which was done by a long time ago, that reported 1,761 languages, and since then we haven't been able to do a thorough survey. Now look at our documented literature, the written literature. Sanskrit is more than 6,000 years, and continuous literature. This is unparalleled, and in any culture of the world, we don't have as much of a span in terms of literary history as we have in Sanskrit, in any other language of the world. And the good thing is that we can still understand what is there in Rig Veda. We practice Rig Veda in day-to-day manner. We have Pali and Prakrit about 2,500 years. But there are controversies that Pali and Prakrit were as old as Sanskrit. I don't deny that. But as per the history of Indian literature and all the documentations, Pali and Prakrit actually progressed from Sanskrit. And so Apabhansha, about 1,500 years ago. And modern Indian language is about 1,000 years. This is what we have. Now, there's a big oral tradition in India, and writing was not considered a preferred skill in India because there was no need to. People believed each other's words. And so there's a big oral tradition in India, and I would say a large population of India still only believes in oral tradition. And we can tell, we can say that they are illiterate, but that doesn't mean they are not knowledgeable. Right? They may not have degrees, the degrees that we have, but they still may be more knowledgeable than what we are. Now, Sanskrit has been a very, very dominant influence on all Indian languages. not only in linguistics, but in other areas of creativity also, in mythology, in themes of literature, in areas of creativity, etc. And we have to acknowledge that besides Sanskrit, Persian in the Middle Ages and English, it has been a very important influence. And then we have, of course, our major languages, the Hindi, Urdu. If we combine them, they are major influence also in other languages, on other languages besides Sanskrit and English. If you look at the language families, we had 5 families, and Damani is dead now, so we have effectively 4 families only. And if you see Indo-Aryan and Dravidian combined, they have approximately more than 97% of population. So there are 4 Dravidian languages in our constitution and 15 Indo-Aryan languages in our constitution. Right? So we have 19 of these languages, of Indian languages. They constitute 97% of speakers. Austroasiatic is Santhali, that is 1.11%, and Tibeto-Burman 2 languages, Bodo and Manipur, and they constitute about 1%. Now, these are the 22 scheduled languages. You see, Devanagari is the most dominant script, followed by Bangla, and then we have Perso-Arabic, which is not Indian script, so to say. It hasn't evolved from Brahmi. Even Roman is a very popular script in India. Konkani is written in Roman as well as Devanagari. So these are the scripts of India, and many languages actually after partition, people which migrated from Pakistan to India, they came with Perso-Arabic script, and while they saw Gurumukhi and Devanagari there, so they became illiterate overnight. And similarly, people from India, they went to Pakistan. They took Gurumukhi and Devanagari, and they were supposed to use Perso-Arabic, so they became illiterate too. And there has been a lot of politics of scripts in India. You see, Old Chiki is the script of Santhali, and officially Devanagari is the script of Santhali. So there's a clash. People do not know Old Chiki, but they can write in Devanagari, but people want Old Chiki actually. Similarly, for Manipur, we have Meitei, where people are more comfortable in Bangla, writing in Bangla. And then there are many scripts which are actually influenced by each other, and also sometimes the conventions of one script goes into other script, and that makes writing very, very complex. So if you are technologically going to handle written documents in India, that will have to handle the complexity of scripts, right, and mixed scripts. Now we have officially 22 languages. Why I'm calling them official? They are scheduled languages, but technically I'm calling them official because they are official languages in their states. Right? And then English is the 23rd very important language, and 37 more applications, I am told, are waiting to be included in the scheduled status of Indian Constitution. And there are, as you know, 1700 plus other languages and varieties. Then most of the Indian people would be bilingual or multilingual, and so is multilingual media, movies. If you see any movie in India, you will not find only one language. There will be always some mixing here and there, right? And similarly, there is a TV industry, print media, education, etc. They're all multilingual. I'm talking about multilingual. If you see a newspaper, for example, Navbharat Times, and you see unnecessarily English words being used in Devanagari script, similar would be the case in Bengali newspaper. English would be mixed. So most of Indian languages content now being created is actually mixed with English. We call it English. And the language policy, education policy, the new education policy has come as a big push to Indian language, which is a good thing. And there are new states getting created, and so the language policy planners have a tough time actually creating a policy which is acceptable to all and which actually benefits languages. Then we have the question of governance in India, the question of health and education. All these have to be delivered actually in people's language. While English is the dominant language of these governance and health, etc., people do not understand English. More than 10% people do not understand English. So it means we are actually governing people, trying to force governance, health and education in a language which people don't understand and speak. So multilinguality, language and script mixing, English, etc., are certainly very, very complex issues, and they make the complexity of Indian situation very, very complex. Now, English, as I briefly referred to, is a very complex phenomenon. There are a lot of socio-psychological, sociological, psychological complex reasons for mixing and switching code. I'm speaking Hindi, suddenly I start speaking English, and sometimes I mix Hindi and English, right? So there are some research done in why people do that, but then that makes a very complex output for our technology to handle. And English can practically be mixed and switched with any of our languages today. And there was a survey done that how much of internet content in Indian language is actually mixed, and it was found that more than 95% of content in Indian languages on the internet are mixed. And the most mixed language actually in India is Telugu, followed by Hindi. So a lot of mixing actually happens. And you can look at the examples, crazy Kia, confused Kia, etc. In Bangla, crazy Kora. So all these things will be there, even in Bollywood or any of the film industry and language. And there are some newspapers in media, they believe that most of the Indian population is younger, right? Average age is 28, 29. So why not use the language they like, which is English. So therefore, there is a business motive in using English in media. NLP tools have to cater to such phenomena, otherwise will not be able to humanly manage this wide phenomena. The actual problems, are being handled by industry. Amazon Alexa is a good example. Google Assistant is a good example. Amazon Alexa, one of my students works there. They are reporting that they are looking at the English variety as the most dominant variety being used by people actually. So all these assistants and technology software have to handle these varieties. Now there are mixed non-standard multimodal communications. Now look at multimodal communications. I'm speaking and I'm gesturing, right? And in India, people move frequently from one culture to other culture, one linguistic zone to other linguistic zone because of government jobs and transfers, etc. And kids adopt the gesturing culture of the place where they move. And therefore, when I'm speaking, my gesturing may not be synchronous with what I'm speaking. It might change when I move to a new region. And there are also non-standard speech data. My speech gets progressively mixed with the area where I move to. And that also leads to a non-standard text data, social media usage, especially the Twitters and Facebooks, etc., are very, very cryptic sometimes, and are very, very kind of shorthand style that people use, and that has to be expanded before machine can actually handle that. And another complexity is our manuscripts, Sanskrit manuscripts, the handwritten text, historical handwritten text. The oldest manuscript might be from the Gupta period, but even that is a huge time span, and we can have a lot of difficulty. And in modern times, we have, land record documents, property documents for a person who was in another state. Now, a state has been divided into a new state. He moves to a new state, and a new language and script is being used. So the property sale documents might have actually multiple languages, multiple scripts. So if you want e-governance to handle that, then e-governance software must be comfortable in handling multiple scripts and languages at the same time. So now ideal, I would call it a robust AI solution for India would be that the software knows all Indian languages, all Indian scripts, mixing of scripts, influencing of other scripts. So for example, Bangla Prishtmatra might appear in Devanagari text, which was rewritten in Bengal region. There has been some manuscripts found in the Bengal region in Devanagari, which had the Bangla influence on Devanagari. And then there are almost dead scripts like we are trying to revive, Grantha, Sharada, Brahmi, etc., etc. Now, another important factor to consider would be the linguistic data, which was coming in more quantity earlier. I'm talking about 20 years ago, was mostly limited to English. On internet, still we have 53% of internet English only. But now, the remaining 50% or 47% is coming from other languages. Now, the data from other languages is coming in large volumes, and then earlier we had monolingual data, now there's multilingual data, mixed data, and the situation is really, really crazy. The kind of data is being built and the speed the data is being created. It's a big, complex data. I call it big linguistic data. It's very, very complex. It becomes more complex when it moves to South Asia and in India, actually. So some examples of such very complex data in India would be, let's say, judicial documents. Our judicial documents, we have one Supreme Court and about 25 high courts, and I guess about 400 or 500 district courts, etc. And in district courts, we have local languages predominantly, with English, of course. And high courts are, I would say, still the scheduled regional language, not the local language, and English. And the Supreme Court, we have mostly English and some, I would say, scheduled language. And recently, Supreme Court released the last 50 years of data, and you would be surprised to see the kind of complexity that the data presents, for the technology industry. We recently had a meeting of all the startups who are specializing in legal AI, processing the legal documents, etc. And they are facing huge amount of problem in getting, sanitized data. So judicial documents is a big thing, and unless we do that, our judicial process wouldn't be very fast. There'd be a lot of pendency of decisions in India, and judicial systems are well known for slow process. So we have to bring AI into it to make it faster. And AI can only succeed in judicial documents unless it is able to understand the judicial language. Judicial language, as in judicial documents, can be presented only if it is sanitized and the machine is able to understand, the layers, which would be maybe in multiple languages. From the FIR, which comes in a handwritten document, it's a handwriting. FIR might be handwriting. To the local district court, which might be in the regional major language. So FIR registered in the local language. It may not be even the scheduled language. Then it goes to the district court, where it might be translated into the regional major language. Then it might go to the High Court, where it might be written in English language, and it goes to Supreme Court again, English or whatever. So there's a lot of complexity. Same code, same case history might have many languages. Administration papers, historical records, sale purchase, all very, very complex. Newspaper and print media, these are being generated on a daily basis, and a lot of in an English newspaper, you find a lot of words in Hindi in English language. Similarly, in Hindi newspapers, you have a lot of words in English rewritten in Devanagari scripts. Literatures are written, oral, and acted, performed. Film and television. I just wanted to check, is the language okay, or should I switch to Hindi? Hello.
It's fine.
Okay,
Carry
good.
on.
Right. Now, the film and television, I mentioned about that, again, very, very complex. I keep on citing the examples of television industry, which is primarily based, and film industry primarily based in Mumbai. But the kind of Hindi they use is influenced by Marathi. For example, Hindi has reflexives. Main apne ghar gaya. Apne is reflexive. Sanskrit swayam. Now, Marathi doesn't have reflexive, so you find in films and televisions, main mere ghar gaya, main mere pita se mila. Now, a lot of these, very implicit mixing, I would call it influence, has to be also handled by machines. Now, Facebook, social media are more mixed because people are brought to one platform. Now, I talked about Sanskrit and Prakrit and Pali manuscripts, a huge big data available for us to handle. And then we have other language historical texts in Persian and Arabic, and also we have a lot of history of Persian and Arabic texts in India, and English, of course, would constitute itself a lot of manuscripts in English language too in India. Now, the documents of British administration. Now, why is big linguistic not the best team getting the project. All of these things are important in India. A big linguistic data in India is huge, it's variable, and it gets created on the fly. Now, I'm told about 60 million people, or 60% of India actually has smartphones, right? And that is a big number. You can imagine. And if all of them are speaking and using internet, a lot of data is being created. If I'm using Amazon to buy something, I may not be speaking, but my behavior creates a lot of data for Amazon. So a lot of data gets created. If I speak on mobile phone, or if I do anything on mobile phone, to deal with the complex data sets, as is typical of big data, we need smart algorithms. Now, we need smarter algorithms in India. Now, I'm telling my software friends that, if you are very confident that you have done a very good algorithm, come and test it in India. If it survives in India, you're good. Right? So any algorithm, theory, platform, they have to survive the Indian Jagannath, I would say the Indian test. And if it succeeds in India, you succeed. Data techniques are constantly evolving because a lot of data is coming now. Data storage techniques are changing. Now we have storage on cloud and terabytes and petabytes, etc., etc. Now, so things are changing because the data explosion that is happening and the data complexity. And now there's a bigger need to interpret data, do data analytics, and create software. So what exactly in this situation computational linguistics mean and how it actually is different? When I say applying computational linguistics to Sanskrit or applying computational linguistics to any other language, what exactly it means? So I'll talk about computational linguistics and in different areas a little later. Now, when I say computational linguistics, it means something, right? So I'm going to explain that. But when I say computational linguistics on Sanskrit, on Bangla, on Hindi, what exactly it means? So for Sanskrit, I would say if you create applications by studying Sanskrit linguistics, Sanskrit language grammar, and text data and dictionary data, and build some software, that would be considered an area of application of computational linguistics on Sanskrit. Similarly for each of the languages. Now the question is, in India, since we have so many languages, are we supposed to apply computational linguistics on each language separately, or we have some common, some common code, and then individual, districts? For example, I do a common code, we call it Bharati or Sanskrit, and then plug it in the Bangla differences, the Santhali differences, and the Tamil differences and Punjabi differences. We call that those plugins. That would be more maintainable and scalable, and of course would be a lot of cost efficient. So that aspect I'm also going to cover. Now, how, when I say IT for Sanskrit, information technology for Sanskrit, and computational linguistics for Sanskrit, how they are different. Now, if the application development is not based on linguistic principles, intelligent computing, then I can simply IT for Sanskrit. For example, I may scan a manuscript, right, create an image, and use HTML to create an ebook. I will not call it computational linguistics application on Sanskrit. I'll call it an unintelligent ebook creation using IT. But that is very useful too, because I'm trying to save a manuscript by creating ebook. But if I'm writing a program which searches that ebook and able to search words and give me the context, that would be intelligent. That cannot be, because we have to do some image technology, image processing technology. Now, how is computational linguistics related to AI? In fact, AI is a younger discipline than computational linguistics. And machine translation, which is a core area of computational linguistics, came earlier, much earlier than AI. AI was coined in 1958. The machine translation was already popular in 50s. There were big projects given in machine translation in America, and there was also a review done of machine translation. So if you look at the kind of relationship of these two areas, so it started in the 40s with encryption, decryption, neural automata. These were the highlights of the decade of the 40s. And neurolinguistics, because war was there, and encryption, decryption was very important. And then all those techniques to process signal and information smartly was talked about. And 50s, of course, machine translation. I said dictionaries and text utilities were done. The war had ended, and there was Cold War, and we had to understand the documents of each other's languages. And 60s was theoretical informatics, complexity in natural language parsing. So people realized that like process document and translate document is not easy unless we are able to completely parse the document. And then parsing is easier for human beings because we do it every day. We understand our communication effortlessly. So in the 70s, the idea came, why not we understand how we do in our brains first, how a human being does parsing for natural languages so effortlessly. And if you understand that, we can try to reduce that to the level of computers and create an AI machine. The 70s and 80s and 90s were logic and inference, unification theories, natural language interfaces, software was considered more accessible if you have a natural language interface to it. And they started talking about bimodal interface and multimodal interface. Now people start thinking ahead, a lot ahead actually. We are still not there when we talk about multimodal interfaces. But people started talking about that in 80s and 90s. Now, with the web coming in a big way in 2000 onwards, we have big data of human communication on the internet. And now that has become the focus point for all AI research. Now, future I see as David Gibbon, my friend, he sees this very, very complicated, very uncertain because data is changing very, very fast. Technology is changing very, very fast. AI was very different in the 70s, 80s, and 90s actually, and then AI now is very different. And AI would be very different tomorrow. Now, if you look at what Alan Turing, I'm talking 40s and 50s, Alan Turing talked about his computing machinery and intelligence. He was the one who gave the mathematical model of computers. And his article is very famous that he should written in 1950. It talks about can computing machinery and intelligence. The argument is can machines think? He begins with this argument. So I recommend all of you who want to come to this field to first read this article. And he gave the concept of a Turing machine, the mathematical model of the computer, and also gave a Turing test, whether a machine is capable of thinking like a human being. And if a machine actually does that, and a machine is able to mimic human speech, human dialogue, then we can call it that it has passed Turing test. I just said AI is also fluid, changing very, very fast. In the 90s, AI was based on Prolog and Lisp as the two programming languages. I did a course in Introduction to AI in 1997 in University of Illinois, Urbana-Champaign. And that course actually was called Introduction to Artificial Intelligence. The course was actually programming in Prolog and programming in Lisp. So all you learn in that course is only these two languages. It was called Introduction to AI. Now, if you do a course in AI, you will be learning machine learning, deep machine learning. Right? Even today, there is a workshop on BERT-based machine learning by Microsoft Research. And people are doing it. Now, so there's a lot of emphasis now on machine learning because the storage capacity of machines have been rising vertically since 2000, and machine learning is becoming more common, but then data complexity is posing challenges to machine learning. Now, the field actually I have been referring to so far now, trying to define it. You have an idea by now what exactly the field is. It's an interdisciplinary field that you have known by now. Linguistics is a very, very important discipline. And therefore, Sanskrit comes in because Sanskrit is the fountainhead of linguistics. I'll talk about that. And computer science, artificial intelligence itself, psychology, philosophy, logic, cognitive science, wherever language applies, all those fields can be part of this a field called linguistics and computational linguistics. What we do in this field, we develop formal and computable model of natural languages. Very important. Formal, which can be defined mechanically in certain frame, and which can also be computable. It has to be formal as well as computable. Not all formal models can be computed, right? So we have to rehash a natural language grammar into a formal mechanism so that it is computable using a programming language. We model human languages using rule-based or statistical methods from a computational perspective. So we create artificial models of natural languages. And see, there was no such concept of artificially modeling human languages before Panini. I mean, before 19th century in Western culture and India, we always had, even before Panini, we had this idea of artificially converting natural language to artificial language. But in the Western world, we didn't have before 19th, before early 20th century, I would say. So how we can convert a natural language sentence or represent it in such a way using this inherent rules and layering of rules in the language or statistical data so that it can be computed. And also all the relevant linguistic questions that you typically come across in natural languages. Can we have computational approaches and methods to solve those issues? These are some of the things that we typically address in computational linguistics. And in AI, as I said, AI is a younger discipline than computational linguistics, but it is normally considered a subfield of artificial intelligence. So we have computational linguistics and NLP as the most important field of AI, because all the other fields excuse me, need to get input in language and get output in language. Now, inference engines done in AI, expert systems, intelligent tutoring systems, vision machines, which take pictures and interpret the pictures, robotics, etc. All of these machines, if you do not include these will not work. These depend on this because all of these have to understand language and respond in language, right? So this becomes the critical and the foundational area of AI. Today, AI is synonymous with machine learning, and that will only happen. AI will only happen if machines understand natural language text. Otherwise, it cannot happen. Now, what is an AI program? Let's try to understand what is an AI program versus a non-AI program. What do we do in AI? So there are two kinds of computer programs. Ordinary programs like business computing, etc., mathematical formula, etc. So you go to website, I just say IT, unintelligent, applications. Like, I buy and sell things on the internet without any tracking of human behavior. That would be called ordinary program, right? But AI programs are those programs which do intelligent searching, intelligent gathering of information, and processing of human language, right? These are AI programs. And two kinds of AI programs are there. The conventional, which basically get trained with grammar and lexicon of the language. So if I train an AI algorithm with the grammar of a language and the dictionary of a language, and then the machine becomes intelligent in that language and is able to answer my questions, we call it a conventionally trained AI program, right? But if we train an AI algorithm with, instead of grammar, we train with a corpora and annotation, and machine gets to be call it machine learning based trained AI program. Today we are in a machine learning based AI program because it is easier to get data on the internet. Now, I just said AI can only happen if computers understand natural language. But the natural language is not easy to understand because it has layers and hierarchies. Natural language sentence that we so effortlessly speak and understand every day, we do not know how many layers before it comes out of our mouth. It goes through a mindless number of processings, and filtering and layering and ranking of the constraints in such a way that only the optimum, the best sentence comes out. Best sentence means the sentence which is understood by the hearer, comes out of our mouth. So that intricate process has to be understood by the AI scientists or cognitive scientists. And that can only happen if you go through linguistics. You understand the layer of sounds, phonetics, we call it in Sanskrit, Swanvigyan, very old discipline in Sanskrit. But the advantage with Sanskrit has been that since we had an oral tradition, we did not believe in writing things, so the text had to be preserved orally. So the science of phonetics developed and phonology developed very, very early. And since we had to maintain the language, morphology, syntax, semantics, entire grammar came with it. So linguistic sciences had to be developed very, very early in India because of our functional requirement of maintaining the tradition. And that is why, because of this science, we have been able to maintain our 6,000 years of unbroken intellectual tradition in India. We can still read and understand Rig Veda. And that is the beauty of Indian linguistic tradition. And therefore, it's very important. If I'm giving a sentence or text for machine, AI machine to understand, the AI machine has to understand the layers in the sentence, the layers in the communication. And if it is spoken utterance that I'm giving to the machine has to understand the sounds and sound combination rules, right? Phonotactics, all those things have to be known by the machine. And phonology, when we combine sounds, right? Morphology, when we build words, develop words, understand words. Syntax, organizing words in a sentence, right? And semantics, how do the sentences or words they communicate meaning? All those things have to be understood by the machine to be able to understand the natural language text. So a natural language text cannot be understood by the machine without unpacking, unraveling the layers that are there in the language. So how to relate it to human-computer interaction? Human-computer interaction is a machine's interaction with a human being. If you're using keyboard and mouse, we call it conventional SCI. I'm interacting with keyboard and mouse. But if I'm interacting with voice or language, for example, I say to my screen, go to the next screen. So my PPT is intelligent, it understands speech. So it becomes intelligent SCI, we call it SCII. Right? The goal of computational linguistics is to make this intelligent communication happen. If I want to make my computer intelligent, I will say go to the next screen. So go to the next screen. In English, Hindi, any language you say, machine has to parse it and convert that to the command which is mapped to the right arrow. You know, a right arrow. When you press right arrow, whatever impact happens by pressing right arrow, that has to come from this natural language string, right? So that is going to happen, and computational linguistics is used actually for that purpose. Therefore, it is connected to human-computer intelligent interaction. Now, its relation with Sanskrit is very, very obvious by now because of the Sanskrit's huge linguistic tradition, very clear way of describing language unambiguously is the key in artificial intelligence. Can we define human language unambiguously? That was the goal of Indian linguistic tradition in India, which culminated, so to say, in Panini, and after Panini, it moved into different directions. One of the important directions was the pedagogy, the grammar pedagogy. Now, one of the papers I normally display is by Rick Briggs, written in 1995 in the AI magazine. There, he talks about that what in AI we are trying to do in the Sanskrit tradition. People have been doing it through Shabdbodh and other techniques. So it might be good for the AI scientists to first understand what Sanskrit community has been doing and start from there to save time. Otherwise, you'll be reinventing the wheel again and again. There was his argument, actually, why a NASA person would need to do that, because NASA needs AI much more perhaps than any other organization. In fact, today AI is needed by every other organization today. Another paper I frequently beam actually is by Nicholas Osler. He talks about Sanskrit studies as a foundation for computational linguistics. And no wonder in JNU Sanskrit Studies Department had the position for computational linguistics when I joined. And we don't have this position in any other department in JNU. So he has his own argument to say that why it is a foundation for computational linguistics. You should read that paper also. Now, Panini's relevance in CL and AI, I'm going to talk about a little bit more on that. Now, I believe I have till 1 o'clock, I guess. Right. Now, Bloomfield's argument, Bloomfield's quote, famous quote, the greatest monument of human intelligence. He talks about Panini's grammar as an indispensable model for description of languages. Human intelligence's greatest monument is Panini's grammar, and more important for me, from my perspective, is that it is an indispensable model for describing natural languages. If I'm describing some language unambiguously, that is the goal of AI, that how can I describe a natural language, Hindi, Punjabi, Gujarati, Marathi, Bangla, etc., unambiguously, so that there can be a model created, computational model created. That can be done by Panini. And he says Panini is an indispensable model. Unfortunately, in India's linguistic departments, Panini is not a highlight. Chomsky is. And that is a contradiction, actually. That is something which you don't understand. Another quote by Encyclopedia I would like to put here. Look at the highlighted one. The grammar in Ashtadhyayi has been likened, compared to the Turing machine, which is an idealized mathematical model that reduces the logical structures of any computing device to its essentials. The idea, the basic idea of Panini is that you take a natural language string, reduce it to its basic essentials, and in doing that, you describe it unambiguously. And that is the goal of AI. And the AI researchers were so frustrated. I'll quote some of the frustrations of the AI researchers. John McCarthy, who actually termed the word AI, he talks about that unless we are able to do that, describe natural languages unambiguously, a machine cannot understand natural linguistics. Unless we do that, machine cannot become intelligent. Now, another quote from Sir Monier Williams, which is the concept of meta-language, was given by Panini 1,000 years before computer scientists began exploring the idea. Meta-language, meta-terms, meta-rules, meta-behavior, meta-processes, all these are very, very important in computer science, artificial intelligence, computer science, any shastra. The meta is very, very important, right? And Panini did it so beautifully in his grammar. Unless we have his meta rules, we don't know where we are going. There's no control mechanism. Unless we have meta rules, there's no control mechanism in Panini. Ashtadhyayi is a functional AI system. Now, I normally view Ashtadhyayi from top. I look at Ashtadhyayi as not as sets of prakaranas, like the Subandh Prakarana, Sandhi Prakarana, Tigant, etc., but as a system of systems, right? This is a common single system which has 4 modules, rather 3 very important modules. The sound module, if I'm speaking to you, and then you don't understand the language. From sound, you go to the language. So therefore, the first component in the grammar must be the phonetic component, which filters sounds and connects it to the letters, the actual language. After you have converted sounds to the letters, now you have the rules of the grammar and the dictionaries of the grammar, and you apply all of them, and you parse the language. What Panini does, it takes all the 4,000 sutras, which are divided into 8 categories, and then he has 2 big dictionaries, Dhatu Path and Ganpat. These are all external dictionaries. In most of the smart AI programs, the data is stored externally. Data is stored on cloud. Data is stored in databases, which are not part of the program itself. So program, which is Sutrapath, is outside, and databases, which are huge data, which is in a different location. Both interact with each other through communication protocol, right? Similarly, when Panini from his Sutrapath says Dhatoh, he goes to the Dhatu Path and establishes the connection. And same protocol is followed whenever you write a database program and connect with the front end, you write a communication protocol, right? So Panini does it from his Sutrapath, he says Dhatoh, and database is assumed inside now. It is still existing outside, but it is assumed to be inside. And then the communication starts happening. And similarly with the Gana part, etc. Now there are small lists, very small sets of things which are internal to the Sutra part, and Panini uses that more frequently. Now, if you compare the Panini's grammar with Chomsky, who's considered the father of the modern, you can say, the contextual grammar, which is the basis of programming languages compilers. Chomsky is the linguist who gave the hierarchy of formal grammars. And one of them was chosen, like contextual grammar, to be the grammar of the compilers, the formal grammar for writing compilers. So I'll compare Panini with Chomsky. Now his model came in 1965, Chomsky's model. Look at his model and compare with Panini's system I showed you in previous slides. So the Chomsky system has the base component and then the transformational component. This component and the transformational component. So his base component has phrase structure rules and lexicon, which is like Sutra part and Dhatu part, Gan part. Right? And when they apply on language, you get the deep structure. In Panini also, the Sutra part, Dhatu part, when they apply on string, you get the meaning. You get the analysis. And analysis of the deep structure in Chomsky, and that leads to the semantic component, the meaning of the utterance. And on the meaning of the utterance, you apply transformational rules and generate the surface string which you are going to produce, which you are going to utter. It's a communication cycle. You hear something in sounds, you parse it into letters or the language strings. Then on language strings, you apply the rules of grammar with lexicon, whether you do Panini model or Chomsky model, the same. And on that analysis, which is you apply some techniques to get the meaning. Chomsky doesn't say that, Panini does say that. And the meaning, you apply other rules to generate the forms which you are going to speak. So this is the model of Chomsky. And you compare Panini now with the contextual grammar. The contextual grammar, which is used in the compiler designs, has a symbol mathematically G, a grammar, which has non-terminals, terminal items, productions, and the start symbol. So this is the grammar. Or when we define grammar formally, non-terminals are the noun phrase, verb phrase, determiner, noun, verb, etc. All the defining, I would call them meta terms. In Panini also we have these terms, of course, Sangya, Samnam, Kriya, but Panini has another sophistication. He creates separate sets of meta terms like Aka, Savarna, Dirgha, Vriddhi, etc. These are also used progressively, iteratively in his grammar. The terminal items are the actual words of the language. When I talk about a language has actual words and the defining words, both. And the set of that makes the language. For example, the dog, cat, etc. are the words from English language, and Panini's could be Devdatta, Udan, etc. And the sounds of E, etc. Those could be all words, the terminal items actually in the language. And then you must have a production mechanism. A goes to B in a given condition, right? And Panini always does that. A goes to B if C, Aka Savarne Dirgha, Ak ka Savarn hoga if Dirg. Ak will become Savarne, Ak will become Dirg if there is a Savarna, right? Or Iko Yanachi. It will become Yan if there is a Ach. Now, Panini always, all his Vidhi Sutras, Panini's Vidhi Sutras are in the format of A goes to B if C. And the similar production mechanism is used in the formal grammar called context-free grammar, which is used in the compiler design. And the S is the start symbol. You have to start somewhere, end somewhere. It has to be a finiteness to the procedure. And a non-terminal alpha, I've defined alpha A as the non-terminal, and alpha is the string of symbols from union T start. Now, language actually is this combination of a set of all the words made from all the vocabulary, non-terminal vocabulary, and the terminal vocabulary. So a language dictionary will have all the words, actual words, and all the defining words, part of speech categories, etc. And you make vocabulary from this. So word from English language would be a combination of all the words and the non-terminals to be drawn from that. Right? This is the formal grammar, contextual grammar. And if you compare Panini with BNF, Backus-Naur form, let us see how it works. So the BNF is a notation system was used for writing contextual grammars, for compiler designs, etc. So how would you write that? See, Noam Chomsky's models came in, 60s, 57 and then 65, etc. At the same time, in IBM, we had people working on the COBOL, etc. Compilers. I'll talk about that subsequently. So we said the sentence goes to noun phrase and verb phrase. This is how, in shorthand, you would write a contextual grammar. And in Panini, you would say a pada goes to sup and thing, because pada is sup thing and the padam in Panini. So this is the Panini, which came earlier. This is the contextual grammar in BNF, which came much later in the 50s and 60s. And similarly, if it's a noun phrase for English language, for modern English language, it will be determiner and noun. And then in Sanskrit, which will be much more abstract, the subanta pada, the sanya pada goes to, this is abstract, this is flexibility, something, and the sanya. So Sundara Devadatta, or only Devadatta, right? Chanchala Sundara cha Devadatta. This can be abstract, and this gives you flexibility in applying this model to any other language, right? And similarly, word phrase could be a verb and a noun phrase in English language, because it's a non-final verb in English language. And in Sanskrit, you can kriya pada will have the kriya centrally, and there could be some element before, some element after, depending on which language this model is being applied to, right? And similarly, a noun category could have words like this, and sanya in Sanskrit could have words like this, it depends. And verbs like this, and in sanya it could be. Now remember, in this model, it is still non-abstract. In Sanskrit, it becomes abstract. Bhu is a very abstracted entity. It's not bhavati, right? A determiner will not be in Indian languages. So this is the CFG in BNF has simplified the definition of programming languages in compiler design. So this is how we can compare. The idea obviously came from Panini. Now, how it came from Panini, we'll trace the history. The idea was that before Panini, I would say before 1950s, in the Western linguistic tradition, they did not realize that grammar of a language could be used to formally model a natural language. This concept of grammar was not there. Grammar was basically which you can use to read and write and speak language, etc. But grammar to model language unambiguously, artificially, this concept wasn't there in the West. So Panini was studied thoroughly by Saussure, and he taught Panini for 30 years. Bloomfield was inspired by his writings, and from Bloomfield you saw his quote. Harris, who was Chomsky's guru, Harris was inspired, and in fact Harris was the one who told Chomsky linguistics. When Chomsky was hired by MIT in the 50s, early 50s, and his 50s in the book came actually there. And Chomsky's idea on his formal grammars actually inspired John Backus, and he gave the Backus normal in IBM, and the Peter Naur also worked on it, and then together it became Backus-Naur form, BNF. People also called it variously Panini-Backus form, Panini-Naur form was also earlier it was used. Now, Panini's technique and abstract notation used in accurately describing natural language is very similar to John Backus, IBM designer, described a new programming language, Algol, no, later became COBOL. This is what, so you can very clearly trace the history. The Panini system is obviously very formal, more formal compared to Chomsky's model, Chomsky's grammar. People try using government binding theory and minimalist approach in language modeling, and they fail miserably when they try Indian languages. And despite that knowledge, Chomsky has done more and more. Chomsky should be studied, no doubt about that, but Panini should be the one we should apply on Indian language, but that actually works. So Panini's model is more stable and largely unambiguous procedures. It's very important, and that makes programming easier. If you have ambiguity in the procedure itself, you can't write code. right? And the Panini's grammar structure is very similar to an actual program, you know. And I've been a software engineer, and I know the similarity between the two systems. And Panini starts with instantiating a variable. We started instantiating a variable in programming also, and then we evaluate variables in program. And in Panini, we do continuous vriddhi. I call vriddhi in this sense expansion. The vriddhi radesh is the first sutra of Panini, and I have my own interpretation. I say the Panini wanted you to know that in his grammar you have to do vriddhi continuously. Unless you do that, you don't understand Panini's grammar at all. So vriddhi, in my sense, as the first sutra, is not really Mangalacharan. It's actually Panini's way of telling you that you have to do vriddhi continuously in my grammar. And you do vriddhi in a programming language code also. If you don't do vriddhi, don't expand the code in programming language, you don't understand. Right? And compiler does that actually. If you are calling some other class inside a class, compiler has to go there, expand it, and try to understand what exactly is being said. Now, phrase structure rules and replacement procedures may have been very clearly influenced by Panini. Now, how can we apply Panini to other natural languages? And right now, I'm focusing on how Panini can help actually, you know, speed up AI. So Panini's module, the phonetics phonology, which are Shiva Sutras and Sandhi, can be applied cross-lingually in any language. I'm trying to apply right now Shiva Sutras to other Indian languages. And Sandhi can be applied to, many Sandhi Sutras can be applied to other languages too. For example, you know, we can say Eko Yanachi, Ik becomes Yan, can be applied cross-lingually. You know, Stos Chunascho can be applied cross-lingually. Even in English also, don't you becomes don't you, right? So many languages can have their rules of sound combination modeled on Panini. Some of the rules will work as it is, as I gave you an example, but some rules have to be modeled in the Panini system. So you get the Panini's meta structure and model English, model Punjabi, model Gujarati, right? And the morphology is much more elaborate in Panini. Some languages are weaker in morphology, like English is, but Indian languages are considered stronger in morphology. Even a weaker morphology language can be modeled on Panini's system. Like, you know, you have primary derivations in English, you have secondary derivations, tadita in English, you have feminine forms in English, and collocations, compounding, and noun and verb phrases, in English language. All those can be modeled, you know, on the Paninian system. And the syntax semantics is very elaborately done in Panini. People say Panini's grammar is weak in syntax. I object to that. Actually, what he calls syntax is not merely ordering of words in a sentence. There's much more to syntax than you generally understand. And Panini talks about that much more, you know, where you move from bare syntax and morphology syntax to the Karaka layer, and you talk about Karaka and Vibhakti. So this is what Panini's cross-lingual applications can happen. Now, Panini as a model, we have been talking about what are the implications, and are we going to have some advantages? The implications are that if we do that, Panini's model is largely unambiguous. Problem in AI has been that none of the models have been unambiguous. The grammars that we had in the West, Chomsky's grammars, and which gave rise to new avatars like HPSG model, lexical functional grammar, so many T-adjoining grammars, so many grammars. All of them have suffered from the same problem of handling the large, the long distance dependencies. These are actually unsolved issues actually by all those grammars. If you look at Panini, and if you try doing the dependency, which is now very popular, the Karaka model of Panini, that can solve all these issues actually. The Karaka model is model on the way we perhaps model our languages in our brains. So Panini's model can be used for other languages than Sanskrit also, and there'll be a lot of advantages to that. And advantages would be, of course, the scalability. You develop a model for language A, and then you scale it and easily use it for language B, language C by adding the plugins. Yeah? But then there are some issues that we have to handle. Panini's grammar itself has a lot of semantics in it, and unless our technology moves to a stage where we are able to compute semantics easily it will be difficult to implement entire Panini, right? There'll be issues, and I can give that talk in a separate layer, not today actually. Now, major areas of study under computational linguistics that we typically do are these areas, but these are not the only area. There are many areas coming up every day. But typically we talk about smart input and output mechanisms. We can give smart input to machine using voice and gestures and or handwriting, and we can get smart output in speech, in gestures, etc. And we can create taggers. We can have natural language text, and can machine automatically scan and tag it. We can have morph analyzers where machines can understand the internal structures of words, right? And do a complete sentence parsing also. And then automatic speech recognition recognize what I'm saying, and type when you speak. So recognizing human speech, recognizing humans who are speaking, and synthesizing speech, generating response in speech, which is very essential. And translating, machine translation is very critical for our languages to survive today. And cross-lingual information access. Not every language on the internet has the same quantity of data available in them. For example, English has 53% of data on internet. Indian languages don't even constitute 1% of data on internet. So if I'm searching for some knowledge, some data in Hindi, and that knowledge is not available in Hindi on the internet, can machine get that information in English and translate and in Hindi and give it to you? So cross-lingual information access is very critical, especially in our language, because we don't have as much internet content available in our language. Automatic localization will be very important. We translate, softwares, content in many languages automatically. Text summaries are very important because we don't want to read the entire document. Instead, we want to read a paragraph or so summary. So that is very important. One of my students is working on summaries for Sanskrit. And name entity recognition is very important. From a text, we identify names of place, people, etc., because they carry the load of semantics. Therefore, identifying names is very important. Now, basically, we have three communication models, communication modes today in AI or in computational linguistics. We either communicate with text, writing, text, not handwriting, but text only. And that's called unimodal. And we communicate with speech. We call it bimodal because we can speech or text. And we communicate with images, which is handwriting, also image. Handwriting, video, gestures, etc. They're all images, and we call that multimodal. And these are done differently because there's a different need in terms of computer processing of these data. That techniques initially differ because we have to understand each data and then get it on the computer first, and then start the processing. So the surface level, we have to have a different filter. We call it a multimodal filter. We get input, and then we pass the input. For example, our eyes are able to pass the visual input. Our ears are able to pass the spoken input. So these are the mechanisms that have to be added to the machine to become intelligent. And after they are able to pass these input, then the processing actually starts. Yeah. Now, how the processing starts, we follow three different kinds of methods and algorithms, various algorithms that are used in these areas. The three basic methods are the rule-based methods. We either look at the text and create grammar for the text and the dictionary for the text, and then we ask machine to learn that grammar and the dictionary and be able to parse the text. That's called rule-based. Typically, we do not write the rules for entire language. We write rules for a small sample that we want to parse. For example, we want to parse, say Abhigan Shakuntalam, or we want to parse all the texts of Kalidasa. So we'll write a Kalidasa specific grammar and a Kalidasa specific dictionary. Not the language dictionary for entire Sanskrit. Many of that will not be used. So we have to basically create a rule-based grammar and dictionary to parse language for intelligent computing. Now, today we have machine learning based because writing grammar rules and be able to update it regularly, and dictionary and update it regularly was considered too tedious and too labor intensive. So instead, we thought there's a lot of data available on internet. Why not take that data and let machine learn or figure out the grammar itself? And that is called machine learning based approaches that are very popular today. And some people also use hybrid methods. The part of the task is solved by writing rules and grammar dictionary, and part of it is solved by doing the machine learning based training. This is called hybrid method. Now, how do you do these machine learning based AI today? There are platforms that you can access. You can open NLP platform, open AI, open NLP platform. It's a Java-based platform. You can download that and then install and then give the matching data to train certain algorithm and do some tasks. Similarly, Python-based, we have a natural language toolkit available in Python, and in JNU we have Indian language corporate initiative annotation platform for Indian language. I'll show you that later on. These are the things. There are many more actually coming up. We have BERT, BERT for done by Google, and also open source. Today there was a training for BERT from Microsoft. So many actually are coming up every day actually. Now, computational linguistics tasks are different, for Sanskrit compared to other languages, as I've been actually emphasizing. For other languages, as I'm going to say, tasks 1, 2, 3 for all Indian languages. I mean, you prepare a software for parsing these languages and helping these languages. Unless we have, say, tools, language technology tools and machine translation and applications for our languages, they will not survive. So that way we are trying to help these languages. But task number 4 will be only specific to Sanskrit, because where Sanskrit can help AI, in speeding up the AI. Let's talk about task number 1, creating urgently needed tools for languages. Especially I'm talking about Indian language, we need to have smart input-output tools for our languages. We have smart keyboards, and I'll tell you how we have done some predictive keyboards for our languages later. And OCR, handwriting recognition. So how I'm writing in hand, can machine recognize it? Can manuscript be recognized? Can speech be recognized? Can text-to-speech be generated? Can multimodal recognition, gesture, etc. be done? All these smart tools have to be created for our languages. And if you have these tools, then anybody in India, no matter whether they are literate or not, they can participate in data creation. A person who is performing, say, a natya in some remote part of the country in any language, that can become text. Machine can generate a natya to text, right? Machine can generate speech to text. So all those things will help create more data for Indian languages if you have smart tools. Conventional tools will not help. Now, manuscript text digitization, preservation, research. This is very important for Sanskrit. Of course, other languages will also have manuscripts for them also. Now, text readers and simplifiers. If there is a very complex text, say in education you have a lesson, an e-learning lesson, a PG Pathshala lesson or something online, and that is very complex and readers are having difficulty. Can machine simplify it for people to read? And also summarizers. Can machine summarize a chapter for someone to understand? And we have to have smart e-learning applications, AI-based applications, e-learning, where e-learning can be done in multiple languages. I'm giving this lecture in English language, and this lecture is on the fly translated and synthesized in multiple languages for all the people in India. So we have to have that kind of tool. And of course, machine translation will be used as an internal process for all such things to happen. Now, create digital resources. This is very more important for Sanskrit than other languages, but other languages also have to have digital resources. But I think this is critical for Sanskrit to have digital library and digital resources. So we have to create a manuscript library, which will have a library of handwritten text, parallel with the electronic text. Now I have a handwritten manuscript scanned, and then another file created out of it, which maps each sentence, each line to actually typed text. So I have an image of a folio of a manuscript, which has, say, 50 lines, handwriting. Then I have another file which has these 50 lines typed. See? So these parallel data have to be created. This will be a very important resource, and only Sanskrit departments actually can do this kind of activity. Now, these electronic texts will be indexed with and cross-linked with. relevant interpretative shastras. And if there are some key words, for example, Ayurveda, we are doing these days, the Ayurveda has certain word like Agni, and Agni has to be interpreted not from Rig Veda but from other Ayurvedic texts and dictionaries to get the real meaning. So the words, the keywords have to be identified, and they have to be hyperlinked to relevant shastras for their extended meaning, comprehensive understanding. And there must be a translation facility from these texts to other languages. So I'm looking at a digital library of heritage texts somewhere in this format. Not only scanned images, but scanned images linked to their text forms and searchable and cross-linking. And a digital library of multimodal text, speech and videos, because much of India still generates speech data, not written data, and video data. So we have to have that data, starting with Sanskrit and other languages also. And this will include performances of natakas, Vedic rituals and performances, right? And part traditions can also happen. Cultural rites and rituals, all those things can be part of that heritage library. Okay. Now, digital mapping of yatras, we have a Panchkoshi yatra and all the religious tourism. Those can be mapped. Those can be mapped easily, even using HTML also. And some people, actually, I know my friends in Germany are doing it. Digital resources of Ayurveda, text, practices, tradition. These are very, very important. Any research on Ayurveda, for example, we have started BSc, MSc degree in Ayurveda. Our Sanskrit department is going to give starting this year. We are getting 20 students who will be enrolling in a program called Ayurveda Biology. So for that, we have to prepare text in digital format. So we have databases of Ayurveda texts already done by our group, actually, in JNU. And these are cross-linked and referenceable. And those will be used by the students actually to know what exactly is there in the text. Now, expert systems in education technology is very, very important. How we can educate our people in India has been a challenge. We have new education policies with very good focus on Indian languages. But how are we going to implement it? How are we going to provide language teachers to everybody in India? How is that possible without machine coming in the picture? So there is a Indian Institute of Translation and Interpretation is also being set up. It was mentioned in the education policy. I was part of that document. There will be an institute coming up in Delhi or Mumbai, which will be like an IIT, and doing all these activities, creating interpretations, translations, automation, etc., on large scale. So obviously, we are looking at technology to implement new education policy. A person demanding his mother tongue for understanding a textbook will get it once if the text is digitized and he clicks a button, puts his headphone, and his entire text is read out to him in his language. Those kinds of things will be possible. An expert system for yoga, expert system for Ayurveda, where you are taught Ayurveda and you're diagnosed with Ayurvedic practices and methods using the expert system, and yoga can train you in yoga. The expert system in yoga can train you, and the expert systems for Vedic traditions in Vedangas. All those things will be very, very critical too. Multimedia presentations for our epics, Ramayana, Mahabharata, including diverse traditions in India and abroad. These can be part of multimedia presentations, other Giti Kavyas, Mahakavyas and Natakas, Purana, Katha, Sahitya. I'm talking about the multimedia presentations of these texts are being done in forms of Natakas and Manchan all across, even sometimes in multiple languages. So all those things can be created in terms of, automated in terms of, the performance goes and the text is being generated. Now, educational technology resources and teaching learning methods have to be created, especially in Corona times. We have to have smart education modes and methods for educating all our Indians in their different languages. Now, this number 4 is very specific to Sanskrit Shastras and AI, because AI needs to also benefit, from the knowledge tradition in Sanskrit. And therefore, in today's times, the data-driven technology, machines need to be trained on web data. Now, the problem is we have web data and machines have to be trained on web data. We need the smart programs which can translate natural language text into collections of sentences. John McCarthy, he was very frustrated. He was the person who actually coined the term artificial intelligence in '58, I believe. And he died, I think, a few years ago, I guess, about 10 years or something. Now, he said we need programs which can translate the natural language data, which is available, a lot of data is available on internet, into a mathematical logical language, which computer can understand. When we talk about mathematical logical language, that is very important in AI. McCarthy also believes that knowledge needed for people to speak to and to understand each other is mostly not encoded in language. The most of the knowledge, when we talk to each other, if you ponder over it, is the meaning that we transmit and communicate. Is it mostly in the sentence that we utter or somewhere else? There's been a huge discussion and debate on that in our tradition. But what he is referring to, the non-linguistic elements which encode meaning, we call it knowledge. And if we knew what it was, both AI and linguistics would be helped. He's saying that if we knew where the knowledge is coming from, where knowledge is encoded in our brain, it will be good for AI as well as linguistics. The mathematical logical language that McCarthy is referring to can be compared with the language and methods of Navinai and Mimamsa interpretation techniques. Would be very, very helpful in that. Now, the mathematical logical language, people who have done Navinai, they know they convert a natural language string unambiguously in an artificial, graphical representation of natural language string is done in Navinai methods and techniques. Of course, that needs to be expanded. And one of my students is actually working in that area. And so a combination of Vyakarana, Nyaya and Mimamsa with relevant AI and computational linguistics techniques would be very, very positive and would yield a lot of results. And therefore, I've been always emphasizing on the Sanskrit departments, which are in large numbers in India and universities. Why are they not revising their curricula and focusing on that aspect of Shastra, which is helpful, both to Sanskrit and to the AI. Now, all said and done, there are Government of India programs which help develop technologies for Indian languages, including Sanskrit. So I'll basically give you a bird's eye view of that very quickly. Now, in the government sector, we have the Ministry of Communication and Information Technology, MCIT, or MIT is called now, and MHRD both fund. MCIT funds more. MHRD also funds, to deliver technologies for languages. In the private space, we have businesses and language groups working in that. In the Indian academia, we have these people that currently working on the languages technology. IIIT, Deepti Mishra is working on machine translation. Chennai, IIT Chennai, Murthy on speech technology, IIT Delhi. Shantanu Chaudhary for OCR, IC Bangalore online handwriting recognition for different languages by A.G. Ramakrishnan. In JNU, we do language technology resources and tools. IIT Bombay, Pushpak Bhattacharya, machine translation coordinate, and CDAC, Hemant Darwari, and IIIT Elizabeth Shirley in Trivandrum, and some other major universities, and will do machine translation and resource creation. Now, the thing is, only major universities and IITs are currently engaged in such activities. This initiative by the government and the funding hasn't really spread out to minor universities. When I made a consortium of 17 universities to create resources for machine learning and translation, we involved a lot of other minor universities also. I'll talk about that. But the Sanskrit computing group is very, very small. Only the 6 people are actually currently working in that, and there's always issues of funding for Sanskrit computing. Industry is working in diverse areas for major languages, of course, where they see a lot of business coming in. So Microsoft, search engine, machine translation, and related tools. Google is now a leader. search engine. They're empty. In fact, the MT of Microsoft and Google both have improved. When I did machine translation for Microsoft in 2013, English to Urdu, it wasn't that good. Now it has improved because of the neural machine. They moved to neural machine translation, deep machine learning based algorithms. And SwiftKey, I consulted with them for creating smart keyboards, and this was acquired by Microsoft. Now it is a Microsoft company. Amazon AI does Amazon Alexa, and one of my students is working there. Samsung is going big guns in AI. I visited the AI center in Bangalore and given a talk over there. They're coming up big actually for Indian languages. Adobe only for document processing. Nuance, not in a big way, but small little ways for input mechanisms, keyboards, etc. Easily AI medical data processing. I'm an advisor of this company. TDIL is a Government of India initiative. Came up in 1991 with a goal to develop technologies for Indian languages. And not too recently, they had identified about 26 premier institutes, R&D organizations to work on language technology research projects. And some of them are here. For example, English to Indian machine translation. Indian language machine translation was CDAC Pune. They're still working on it. English to Indian language machine translation again. Another method to Angla Bharati at Kanpur. With Arab Kisana group, Arab Kisana is no more, but some people are still working there, I believe. Indian language to Indian language machine translation, Triple IT Hyderabad, I mentioned Deepthi Sharma. And Sanskrit to Hindi machine translation was given to Hyderabad, JNU, etc., 5 other partners. And document recognition system, were an OCR project to IIT Delhi, Shantanu Chaudhary. Online handwriting to IC Bangalore, cross-lingual information to Bhattacharya, IIT Bombay, and speech to corporate technology to IIT Chennai, led by Himamurthy, another person. And Indian language corpora, I mentioned about 17 language university consortia. So I join you. Now, what we have done for Sanskrit, in a nutshell, what we have done for Sanskrit and other Indian languages in JNU. So our projects had a Sanskrit to Hindi machine translation under Hyderabad and the university consortium, and shallow parser tools project with Hyderabad University and 11 other universities. Still kind of going, not completed yet, this project. And Indian Languages Corpora Initiative, we finished that project with 17 languages corpora, and JNU was the consortia leader. We created a parallel, biggest Indian language corpora, and so great demand actually. This corpora is in great demand. You can search for it online and you get information about it. And we do a lot of consultancies for Nuance. We helped build Kashmiri keyboard. For SwiftKey, we helped develop, create Sanskrit, Santhali, Manipuri, Maithili, Sindhi particular keyboard. In fact, you can download SwiftKey keyboard for Sanskrit from Google Play Store and work on it. It basically predicts the next word that you're going to type. Online handwriting recognition we did for Microsoft 2006 for Devanagari, and with the hope that this would be translated to recognize Sanskrit manuscript someday. Multimodal data for 8 security-sensitive languages for University of Pennsylvania, LDC, Linguistic Data Consortium, Indian English, Hindi, Urdu, Tamil, Bangla, Punjabi, Pashto, and Dari. Pashto, Dari are Afghanistan, Pakistan languages, and these are considered security-sensitive because terrorists might be going through US airports scanning system and speaking the mother tongue, so they can be identified based on the mother tongue which country they are from actually. So no need to racially profile them. Now Microsoft Translator Hub, we did that for Microsoft and created English to Urdu machine translation, released in 2013. You go to a website, you can still see in partnership with Jawaharlal Nehru University. The link, if you give English here, Urdu here, it translates and you get the link and the name of our department. At that time, we were a special center for Sanskrit studies. And so we get JNU's link there. And on the same platform, we have trained English to Gujarati. One direction, we have to do reverse direction, English to Sindhi. And Sanskrit English was done with not good results. And Sanskrit Hindi was done with good results, ordinary Sanskrit. And we are reversing Hindi to Sanskrit with one of my PhD students. Rajneesh Pandey was able to do Sanskrit to Hindi with good results and a very good publication. And then we are reversing that Hindi to Sanskrit. And after that is done, we'll be posting it here directly, right? So you should watch out for our Sanskrit translator. Now we have some monster tools on our server to be downloaded free. They can be used to create very quickly corpora for machine learning for languages which do not have corpora. Now today the thing is, if you want to build tools for any language, A, B, C, D, that language must have a good size corpora and dictionaries, right? And if you don't have a good size corpora and dictionary in your language, you can't build any AI tool, out of that. And to do that, you can download my tool, as a crawler platform, which is crawler sanitizer dictionary platform from my server, and run that to create this corpora for your language. A lot of our students do PhD, as was said by Manji. We have more than 30 PhD, more than 30 PhD, 40 MPhil, etc. And all of their work is hosted on my server called Sanskrit, and I show the work that they have done. And the tools that results from there is sometimes hyperlinked. Now we showcase our development to international fora. I'm part of several international fora. One of them is the Language Resource Evaluation Conference. And we every 2 years they do a conference, and we do a workshop under that conference called Workshop on Indian Language Data Resource Evaluation. Recently we did the 5th one. It's supposed to be held in May in France, but we did online because of the corona. And we do that every 2 years. And whatever development happens in 2 years, we showcase. So whatever Indian language technology developments have happened in 2 years, we put that together and present it to the international community to benefit from what they have done and what we are doing. We also did a white paper evaluation of Indian languages technology resources. So we did a conference where we asked people to present what they have done for their language, and you can see. And in the process, we created white papers. Like a white paper for Bangla, white paper for Sanskrit, which will have the entire resource creation information. Who has done what for Bangla, and what is the current status of that? So kind of a white paper, the status document for language technology in each language. And we are waiting it to be published. This was done on the European model. They have done similar work, and we got to know about that when I was in Germany. So I gave a talk at German Center for Artificial Intelligence, and they showed me the white papers they had done for European languages, and based on that, created this initiative in GNU, and we hope that very soon we'll be able to publish those white papers. Now, the two links that you should search for Calling at JNU as YouTube channel. We have all the videos of the lectures that we do, lectures and seminars that we do, and you should also go to our site, sanskrit.jnu.ac.in, and to know we have lexical resources in terms of dictionaries, indices, textual digitizations, etc. All those things are there, and we have corpora related work, including our Indian language corpora server platform is there, and then language processing tools, many of them, and then we have our seminars organized, etc. All those details would be there, and our Sharda project could be here, and all the proceedings of our seminar, that we do can be downloaded from here. So I'll quickly show you our some of the program that we have done. Let me show you Ayurveda. Now we are running. We are currently doing a Ayurveda program. It's called MSc BSc integrated program in Ayurveda biology, and so we have see that text. So we search our Sushru Samhita. There are so Tantra, Purva, Uttar Tantra, we search Purva Tantra. We have the sthanas, and then you search Asthana, you get Adhyayas. Then you click on Adhyaya, you get indices created on the fly. So what it does, you can tease the text also, as well as you can search a keyword here, and then you search a keyword in that text with exact reference, etc., and then you search on other, Amar course, etc. If this word, as you found in Sushru Samhita, can be searched on Mahabharata, Chicago University Dictionary, Apti Dictionary, our own Apti Dictionary, all those things, can be searched right away. So these are basically the search engines for Ayurveda. I can go to other Ayurveda. We have the Shishva Charak Samhita, Charak Samhita, Mahaprakash Nighantus, herbs search, Amarkosha, etc. Although Amarkosha has a herbs a category of words. So all those things are there, and the more text will be coming actually subsequently here. Then I can take you through a search. There are a lot of grammar tools that you can search. So let me quickly search some word here. Again, our Rig Veda, you can search words like it's a very important word for dating the Rig Veda. Rohini. You can search, find what exactly a reference of Rohini in Rig Veda. Then you can go to search Mahabharata, and you find Mahabharata is our database that Rohini are following occurrences of Rohini. So you get Rohini in the context of some story in Nal Damayanti. Then you search Amar Kosha, and you see Rohini comes in the context of a cow, and then you search Apti Dictionary, and so idea is that you take a word and start searching it all across connected dictionaries and resources that we have to get the complete meaning. And similarly, you can search past text. We have our e-learning where you can do our e-learning and go to all the other tools. I mean, many of you have already gone there. We have e-learning software and animated stories, etc. I can recommend you to go there and search. And I'll very quickly show you our Corpora that I referred to, our Corpora platform, where I can log in. This is my live server. I can log in and take you to our Bangla Corpora and show you Bangla. Our Bangla partner was Niladri Shekhar Das from ISI Kolkata. He was my partner for Bangla Corpora. So you can download, say, for example, you can't download it, you have to have a password, but I'll show you, this is our Corpora file from the entertainment domain. So idea was that we took Hindi entertainment data, this number, and translate that sentence into Bangla, and then tag it using part of speech tagging mechanism. And when you get this sentence, you get this ID. This ID gives you the entire metadata, where this sentence was originally collected from, and what subdomain of this entertainment. Entertainment is a domain which has several subdomains. This sentence actually belongs. Entire information can be obtained by running a simple query of this sentence. And now I'll show you some of the how the process was. We took say the Hindi sentence in agriculture domain and translate it to Bangla and then tag it, right? Then I'll show you how we tag data actually. So I select a corpora, and then see this is our Bangla sentence, and then we tag it. We tag it, so tag interface starts, and we select for every word what is the possible tag. What machine does, has learned automatic tagging from the tagging experience of the annotators. Machine has learned. So when you open this sentence, machine will automatically assign some tag to the words, and then you correct it. If there is some error, you correct it, adjust it. In the process, you can also add new words, etc. To the tag. exact dictionary. So let me take you to our another interface where I want to show you how we have been able to chunk the data. So I can select a corpora and then chunk it. Chunking is assigning the phrase boundaries, right? The groups of categories into one broader category. So if I say chunk here, then it opens the interface where you start a chunk here, end a chunk here, start this chunk, end here, and this you assign, and then you save. It becomes gets chunked. This is how we have, and this data can be very easily used to train a chunker for any language. Once we have a very good annotated data, we can use it to chunk. Now this is our corpora, which is very high in demand, and we recently had a meeting. We had a meeting actually at TDIL. Several rounds of meeting which were attended by industry also, including Google. And what should be the price for each of this corpora? So on average we have 1 crore rupees fixed as a price for one language data. And currently CDAC has sent me a document, a contract that I have to sign. Once I sign it, that corpora becomes available. But JNU has to give me permission to sign the document. There are some agreement issues actually between CDAC and JNU. We are trying to resolve those agreement issues, and once that is, meanwhile I got an offer from ELRA to host our data there, but we can't actually do that. So I'm looking at to resolve these contractual agreement issues between JNU and CDAC very soon, and be able to sign the document, and then the corpora becomes available for sale. Now, once the corpora is sold, suppose we have our Bangla corpora sold, bought by say Google, then the money comes to JNU, and the money is distributed between JNU and ISA Kolkata. This is the mechanism that has been already worked out, and document is there by the ministry. We are waiting to be hosted by CDAC very soon. So I'll say thank you so much, and I loved giving this lecture in a university, and so honored to be part of this lecture. Manji has been telling me that whenever I come to that area, I should visit the university, but I'm in such a short trips that I have been to various places. I say Kolkata, to Shanti Niketan, and CDAC several times, and even to Dhaka I went actually for giving keynote talks to actually Sylhet actually to Shahjalal University, but never got time to actually stop over in Bankura. But this is a good time now. We are able to talk actually no matter where we are, without spending a lot of time and effort. We can very quickly talk to people. So thank you so much. I'll stop sharing, and I can take questions if there are.
Thank you, sir. There are questions. One is from Santosh Kumar Panda. He's asking, sir, if you want to do research on any particular language, then how can we get the data set of that language? Is there any source where we can get, or we have to make our own data set?
No, you can get it free. You can get ILCI corpora free by downloading it from the tdil.in website. It's a very simple form that you have to fill, and you download the form, fill it up, very few information, and then your supervisor signs it. You upload it on the server, and you get it free of cost. But if there's an industry or private people, they have to buy it. For academic institutions, it is free.
Okay. And sir, another question is from Vishwaranjan Das. Sir, is there any relation between Panini grammar and CFG as compiler concerned?
There's a very clear relationship which I showed in my talk. But if you ask a person who is doing compiler design or writing compilers for programming languages, he wouldn't know about it because he never read about it. So the idea is the Sanskritists themselves are to blame. They did not study that perspective of language. From Panini, they should have gone beyond and studied a little bit of Chomsky, and then see the comparison, and then talked about it to research papers. Now, with this Sanskrit computing group here and there, they are gradually coming up. So I believe in times to come, this will be known to people. Yes, there's very clear connection, as I showed in 3 or 4 of my slides. Very clear connection. As it is known in some of the academic circles, but may not be known by a developer who is actually developing Companion.
Okay, sir. Another question is.
Can you wait a second? I have to add a charger to my laptop.
Yes, sir.
Yeah, sorry. Yeah.
Yeah. Another question is from Shudit Dash. He's asking for a suggestion. He's saying that I am developing my own Sanskrit Shikshan Paddhati. After completing the method, I want to apply for its patent. I want to develop it as a Sanskrit learning software. How can I go for it? Will you please show me the path?
Yeah, patenting is a process that can be done through your university if you are a university. If you're not in a university, then you have to file a patent. You go to internet and see the procedure of filing a patent. You may have to go to a lawyer, I guess, who can file for it. But idea is, if you have a very good idea, I would say there are funders available. People who fund good ideas. So go for startup innovations, etc. on the internet, and look for some people who can actually fund these ideas. And there are meetings where you can go to the meetings and present your idea and let people see if there is a merit in funding that idea. These are the things. But if you are in a university, you might go through your IPR cell and apply for the patent. But the easiest thing is, the problem is people steal each other's ideas. The best thing would be how in America people protect their interests. You write a letter to yourself, registered letter to yourself. Okay, and in that you write a page about your idea. And you mail it to yourself with a registered thing. So that mail comes to you and the envelope has the stamp. You don't open the envelope. So that is a proof that you created this idea on this date. So anybody, if someone steals the idea, say this is the idea was created by me on this date. Envelope is sealed. And it has a stamp of the post office. So that's one way of, before you go present your idea to anybody, any venture capitalist, I would say, protect your idea by this method first. Because people do steal ideas.
Yeah. Okay, there's another question from Kolani Das. Is Panini grammar useful to learn Java or Python?
Well, I have found that good linguists, good linguists who are trained linguists, like I didn't have a formal degree in computer science. So people who are trained linguists or trained in Sanskrit grammar, yes, they can quickly learn programming. And our students in JNU learn programming very fast. My experience is that.
Yeah, Divakar is the best example, I think. Divakar Mishra.
Divakar, Atul, Ritesh, Subhash, a lot of people actually, have picked up programming very well.
Sir, I remember
Kabir is also a good programmer.
Kabir is also doing very well, yes. So I remember that once, Divakar used to solve problems faster than MCA guys.
Sorry, I did hear that.
I mean, in our project, when we were all students, there were some MCA passed, developer, okay, in our project. Divakar used to solve problems faster than them. Yeah, I remember. Another question is from Vishwajit Raj. Sir, he's asking that either we have lack of knowledge in IT or in Sanskrit language. Like, how can we solve this problem in basic level?
Very good question. I have been actually shouting about it, No one stops a Sanskrit department in giving science degrees, right? As an example, we proved that in JNU, we started giving science degrees, MSc, BSc in Ayurveda biology, right? So government doesn't stop you from doing it. So why not these Sanskrit universities? They start a course in MS degrees, MS degrees in AI, Sanskrit AI, something like that. MS degree in computational linguistics. We started a certificate course in computational linguistics in JNU. Okay? So Sanskrit departments can start that, and if the control is the Sanskrit department, then things will evolve in a much better way. If the control is given to some other department, then you will lose the initiative. I think that these Sanskrit departments, universities, should evolve carefully constructed programs which further the knowledge of Shastras and the AI together. That will be very, very useful. That will benefit AI also. And I'm sure if there is such a program created and you go to Google or some other group for funding, I'm sure they will be more than interested to see merit in such initiatives.
Sir, I have a question. Sir,
Yeah.
I have question. Sir, in like you have mentioned about deep structure and surface structure in Chomsky's Jibit theory, but in minimalism, they have scrapped it. Like they don't talk about anymore the surface structure and deep structure. So can you elaborate on this little bit? I mean,
Right. The minimalism is a more condensed model, but it's not that deep and surface structure are not there. They are there actually. So what they are talking about maximally defining a lexical item. In that is they're coming very close to Panini again. Now, say for example, I say any word like who is the maximum definition of all the forms that bhu can generate. All of them can be understood by the entity bhu. And by knowing all the possible channels it can go to, right? So it's going towards that kind of a model where we have a very condensed model, and they call it minimalist in the sense that you don't do too many things, right? So it's a very condensing of the model. But yes, the deep and surface structures are not completely given away; they are inherently there. So it's a improvement on the Chomsky's existing model. It's not that Chomsky has replaced his government and binding theory with the new model. It's not like that. Chomsky evolves. See, from the aspects of theory of syntax, to something else, and then to the government binding, and then to the minimalism. X bar syntax also came before government binding theory. All of that basically started solving questions and criticisms that people came up with the transformational component, right? So brain actually essentially does transformations. There must be some simultaneous processing or step-by-step processing, sequential processing that we don't know. People are basically guessing about that. But there are these processes being done in the brain. And Chomsky wasn't wrong when he said that in 1965 or 1957.
yes. Sir, there are no more questions. Shonto, can I go for the Thanksgiving first? Hello?
There's a question by Vishijit Raj. Sir,
Oh, there is. Okay. There's. Okay, he's asking, practicing randomly combined language like English or Benglish, is it dangerous approach to the existence of our regional languages like Bengali?
Well, see, language is used by the people, right? And you can't force people to be more purist and not use mixed language. One of the problems they have that the English terms are easily available to them. And they also want to impress. English is a language that people think is hip and fashionable, so people want to impress, so they want to mix. So mixing is done because of many reasons, sociological, psychological, and functional reasons, etc. So we can't stop people from doing that. And the question is, can we, from the mixed language, derive the standard language? So software can do it. So there's no question of language being corrupted or language dying, etc. Software can take care of that. Let people use whatever they want to use it, but what gets written is the standard language. That's possible. Let people speak the mixed language, but what gets written will be the standard language. That software can do.
Sir,
Hello.
there are no more questions.
Okay.
So, Shantu, can I go to the Thanksgiving part?
Yes.
Yeah. Thank you, sir. एतावत् there is one more question. एतावत् कालपर्यन्तं महाभागानाम् अमूल्यज्ञानवादिना वयं सर्वे स्नाताः सिद्धाश्च तदर्थं महाभागेभ्यः भूयांसि नमांसि तथा भूयांसः धन्यवादाः विज्ञापन्ते। अस्माकं विश्वविद्यालयस्य कुलपतिः श्री देवनारायण बंदोपाध्याय महाभागेभ्यः धन्यवादं व्याहरामि। अस्माकं विश्वविद्यालयस्य कुलसचिव श्री सुबीर राय महाभागेभ्यः धन्यवादं विज्ञापयामि। विभागाध्यक्षं सहकर्मिणः प्रति अपि धन्यवादः। यांत्रिक सहायकान् प्रति धन्यवादः। पुनश्च श्रोतृभ्यः अपि धन्यवादः विज्ञापन्ते। अन्तिमे शान्ति मन्त्रपाठार्थं सन्तु महाभागम् आह्वयते। सन्तु।
ओम श्री गुरुभ्यो नमः। हरिः ओम। ओम आप्यायन्तु ममाङ्गानि वा प्राणश्चक्षुश्रोत्रमतो बलमिन्द्रियाणि च सर्वाणि सर्वं ब्रह्मोपनिषदं माहं ब्रह्म निराकुर्याम् मा ब्रह्म निराकरोत्। अनिराकरणमस्तु अनिराकरणं मे अस्तु तदात्मनि निरतेय उपनिषत्सु धर्मास्ते मयि सन्तु ते मयि सन्तु। ॐ शान्ति शान्ति शान्तिः। हरिः ॐ तत्सत्। श्रीरामकृष्णार्पणमस्तु।
Thank you. So I'm quitting. Thank you, everybody.
सर हमारा प्रणाम स्वीकार करिए।
Thank you. बहुत बहुत धन्यवाद. Thank you.
ঠিক আছে।
হ্যাঁ চলো তারা